Hello, everybody. Apropos is a conversation between Clojure programmers that you can join in live. We're going to discuss a few Clojure news items and share our opinions on them. Then we'll jump into a REPL and code some exercises or do some demos. If you're joining us live, feel free to comment in the chat and we'll try to address the questions. All right, so with me today, or all of us, it's not me hosting it, we're all together. We got four of us. We got Mia. Say hi, Mia. We got Mike.
Hello.
We got Ray.
Hey.
And I am Eric. So let's begin. What's up first? Looks like what we got is a code cringe fest. I believe that I tweeted something that inspired this, and the idea is that in the last show we did some demos of us solving an exercise, and several of the attempts at solving the exercise didn't actually work, and so there was a lot of flailing from the panel. And my experience has been that every time I've published a flailing video of myself showing like what it's kind of like really like to program, people have been happier to see that than to see me just do it right the first time because I've practiced it or something. So I guess that's what we're talking about now.
I thought that the Code Cringe Fest section was just like us doing live coding at the REPL like all the time. Like I thought that's just what the section is called.
That's the name of it.
Yeah.
Right, maybe it should be.
Yeah.
The Clojure apropos flail along. Flail at home along with us.
I mean, I think it's a fair thing to think about though. Like, I did a boot camp. So people are always asking me like, oh, you were not in computer science. Like, do you think that I should study computer science? Do you think I should go to a boot camp? Do you think I should learn to code? And I always tell them, like, are you okay just failing over and over again and trying to fail a different way every time? Like, are you okay with that being the definition of success? Because that's really what success looks like most of the time, is just a different kind of failing. And I think it's reassuring to see that is true for everyone.
Success is just failing better than you did last time.
If you fail in a way you expect to fail, you've won.
I also contest that, I think we are a bit, we're relatively, you guys anyway, are quite humble. I'm somewhat humble. But I don't think we failed. I don't think there was a failure. I think most of the exercises ended up working. I think it was pretty good. And I think some of the solutions were quite interesting. Certainly people who've had hours or days to think about these things that can publish their one-liner on Twitter. I think there were some beautiful bits of work. I was really happy with the feedback we got. That was really good. But I think we did all right. I don't think there's a big problem. And also, remember, the whole point about this was to actually do that, to sort of fiddle with these things and to talk about what the options were and go down some dead ends and, deliberately kind of challenge ourselves to think about other ways of doing stuff. So, yeah, I haven't got a problem with it.
Yeah, I think to me, this is normal development, Yeah. You basically make a mess of things and then you clean it up before you commit it, so that other people can read it. I mean, I think you end up writing the worst imperative code and you're like, oh, wait, let me restructure this. And then you get nice and clean before you commit it.
Yeah.
I think it's completely normal.
Awesome. Yeah. So we're just going to continue the way we've been on those things, I guess. Seems like we're doing it right.
I reckon.
Yeah. So the next item, if anyone else, if we're done with that, looks like we have a feed nowadays, and the first episode, which we recorded a couple of weeks ago, is up. And so I'm going to paste this link, if I can, into the chat.
You mean the podcast feed, Eric?
Yes, it's the podcast feed. So the podcast just has us talking, that first section, and not the REPL development, because you can't see that on a podcast.
Yeah, we thought about putting that bit out, but you know, we decided to edit the torture.
Okay, well, it's not letting me paste a link, so I don't know how to fix that.
Well, the link is on the Twitters, so that's...
Yeah. There you go. Search through every tweet, and you'll find it.
So far, the feedback is wholly negative, you know, that it's totally pointless. So, you know, we'll see what people think after a few weeks.
Yeah, I mean, especially talk like this, where we're talking about, and this is going to be on the podcast. It's like, I'm already on the podcast. Like, why do I care?
Yeah.
Okay, speaking of which, let's move on to the next thing. I think Mike has something to talk about with cljs eval.
So, yeah, I could talk about that. Recently, the ability to do eval directly in the cljs core namespace was added. And if you say, well, you know, Clojurescript can't really do eval, it never has been able to. So you might ask, like, why was that added there? And the real motivation is that you can have eval inside of macros. And there actually is an eval call inside of one of the spec macros. So if you try to compile that namespace using self-hosted Clojurescript, you'll hit this eval call, and self-hosted Clojurescript is being compiled as Clojurescript. It compiles the macros as Clojurescript, and because of that, it can't process that eval call. So it basically would fail compilation at that point. What you can do is you can kind of monkey patch that namespace. You can jam an eval right in there, and kind of make the compiler happy. And you can do that because in self-hosted Clojurescript, you have the ability to eval. You can make up your own eval. So what we did was we put the ability to eval in the self-hosted namespace cljs.js. There's an implementation in there that hooks into the regular eval that it can do. And then that is, I guess, for lack of a better way of describing it, is it sets the dynamic var with the earmuffs eval that's in the main namespace. So that essentially, if you are using self-hosted Clojurescript, the short story is that you then have an eval that works.
But does it work at runtime too?
Yeah, it's practically like Clojure. Yeah.
Okay.
Yeah, so it's not just for macros for compile time. A side effect, like you said, Eric, is that you can actually, at your REPL, call eval like you normally would with Clojure. That was not really the intent of it. That was motivated basically by this macro namespace issue. So that if you do have code, one goal of self-hosted Clojurescript is that it be able to compile regular Clojurescript code, including macros, and macros can have eval in them because the macros are written in Clojure. So you'd like to be able to compile those as well in self-hosted Clojurescript. So that kind of closes out this one last thing that you couldn't do. And specifically, it was causing a problem with the spec namespace that was doing eval during macro expansion. I don't even know why it's doing that, but it's in there.
So just a quickie on that one, Mike, then. I mean, why... So sorry, everybody. Okay. But why are all the macros written in Clojure and not in Clojurescript? Why can't we write Clojurescript macros in Clojurescript?
Okay, so I guess that's the question is, like, if you are you basically asking why can't self-hosted Clojurescript be more like Clojure, where you can intermix macros and functions? Is that the core of the question that you're asking?
Well, you seem to say that macros are written in Clojure.
Yeah.
But what's the difference between Clojure and Clojurescript? I mean, in that sense, what is preventing me from writing my macro in Clojurescript? If I want to do some JS interop, for instance, and get some boilerplate in JavaScript, Like, let's say I want to
yeah.
get rid of all this target crap that you have to deal with. So if I want to do some, some macro binding, you get my point.
Yeah,
here,
I think I understand what you're saying. I think maybe an answer that might satisfy you is that macros are kind of a compile time thing. And with Clojurescript, you want to do everything up front. You want to compile everything down to JavaScript. So it's a very AOT centric approach overall. So you have this compilation stage that you normally have on your in your dev environment, and you compile it down all the way down to JavaScript, and then you even pass that through the Clojure compiler to minify that. So you can't just have macros floating around in your Clojurescript code because they're kind of like compile time constructs. Now with self-hosted Clojurescript, you could theoretically have that occurring. I don't even know if that answers your question, Ray. I'm not sure.
Is it because macros get expanded before the JavaScript code generation happens?
Yes, I mean it's basically a compile time thing that is occurring first. Mm-hmm. So you can't really have I mean you can't have your macros expanding at runtime.
Because you have to compile them to JavaScript and then run them in some environment that hasn't been set up yet by your code. It just doesn't make sense because JavaScript or Clojurescript is more like a compiled language with a pipeline.
Essentially,
whereas Clojure is a dynamic language with a circle, right? Where you get to use the current environment to compile the next environment. And you just don't have that runtime environment you have in Clojure.
Yeah. And with self-hosted Clojurescript, it is more like Clojure. And the fact that the runtime environment that you're in is the very same environment that you're using to compile things. And you get that circle again with self-hosted Clojurescript.
Cool.
Yeah. I don't know if that's a satisfying answer, but I think that's the main naive way to explain it is compile time versus runtime.
But getting real about that then, because if I wanted to, like I know with self-hosted Clojure, I can access the DOM. And if I wanted to write a macro that accessed the DOM in Clojurescript, would that work?
I guess you could have a macro that expands to something that accesses the DOM.
Yeah, exactly. That's what I mean. Yeah.
In that macro, you would normally, historically, just write that in Clojure. I mean, the compiler.
It's kind of what I'm trying to get to, Is like, what do you mean by that?
Okay.
I'm requesting of it.
Yeah. Why is it in Clojure? Well, the Clojurescript compiler is written in Clojure and it's running in Clojure. So in order to compile, it's basically running Clojure all the time. And during macro expansion, it calls your Clojure-based macro that you wrote.
But it that Clojure macro outputs Clojurescript code.
Yes.
Which then gets compiled
by the Clojure-based Clojure. Yeah.
So the macros are kind of weird in Clojurescript because they're not Clojure to Clojure. They are Clojurescript to Clojurescript, but they're written in Clojure.
I think I like that explanation. Yeah.
I don't get it, but okay.
It's like layers of an onion,
Yes.
Or compilation stages, one above the other. Yeah.
Right. And so a lot of macros broke when people started using cljs, right? Because they were expecting to have the environment or to have they weren't expecting that they would have to output Clojurescript code. They were, and that that stuff would I don't know. It just seems like what you want to do, Ray, where you're like reading the DOM in the code of the macro. You're not running in the browser, so there is no DOM. You're in the Java environment.
Yeah. So maybe another way to say that is during macro expansion, the code that you're running while the macro is expanding is in Clojure. You're not in your JavaScript runtime environment at that point.
Right. But you can still emit code that will read the DOM.
Yeah.
Or generate DOM like that. There was a library in the early days of Clojurescript that was called DOMI. That was basically it was kind of a jQuery replacement. It replaced part of jQuery, all the selectors and, get the text or the attributes. And what it would do is it was based on macros. So it would, in jQuery, you give it a string that's the selector. And that string can be really complicated. It could be like class within a class within a class, and then all the divs in there,
it's like
right?
a CSS selector, isn't it? Yeah.
Right. And so that would need to be parsed at runtime and turned into a series of selectors somehow, right? And or like individual like class lookup selectors. And what Dami did was it did all that parsing of the string at compile time and turned it into code that did the equivalent selectors. And so it was in theory faster because it didn't have to parse or walk the data structure that it got parsed into. It could just do it directly. And it was the same for other things that it could eliminate that runtime work.
Yeah, it's kind of like an optimization.
It's an optimization.
Another way to make you happy, Ray, is that if you have like a macro that is not during expansion doing anything weird, if it's like a clean macro that is like a normal, like if you think about almost all the macros in Clojure core that just kind of like takes some stuff and expand it to something else that can then be compiled, but doesn't really, but none of that depends on the runtime environment. Those kind of clean macros, it doesn't really, those don't really matter. The fact that they're written in Clojure doesn't really matter. And that's how self-hosted Clojurescript can also compile them. Because in self-hosted Clojurescript, you only have the Clojurescript compiler there. So all those macros, even though they're in a CLJ file, they're being compiled as Clojurescript at that point.
Right.
So those clean macros, it's almost like you could just step back and pretend like, they're all just written in this pure language called Clojure, and don't even think about a difference between Clojurescript and Clojure. And those are like, those all work out. Yeah. So this weirdness that just happened recently was because of the call to eval sitting in there, and the eval doesn't exist in Clojure, and then you get into this mind bending thing of like, well, what does this really mean?
What does it mean to eval?
Yeah.
In a compiled language.
Yeah. During expansion. Yeah.
Well, what you could do is make the eval call a macro that actually generates the code for whatever code is inside the eval, and then it just runs it. It's just a pass through for the compiler.
Yeah, I was wondering that. Like, do you actually ever need to call eval during expansion? I was trying to think of a good example of like where you would actually need to reach for eval. Couldn't you just write another macro or just rearrange your macro in some way to?
Yeah, it's weird. Also, because eval is not as useful as you'd think because it's based on it doesn't let you pass in an environment. So it runs the code in the current environment, right? So you could generate this code in one environment, with all these let bindings and stuff. And then when you run it, it's somewhere else. And so you don't have the same let bindings. And very often I realize I didn't really want to eval because I wanted to capture that environment. And so it would be much better to instead of capturing the code as data that I can then eval later, I should capture the code in a Clojure, in a function that I could just call later, because that would capture the environment it's in. So yeah, eval is not as useful as it seems.
Yeah. And even though we now essentially have eval in self-hosted Clojurescript, you could say, so what? You don't use it that much. Do you find yourself calling eval that? It's really cool to play with from an intellectual standpoint, right? You can I can do really cool things, but do you actually use it day to day? I mean, how many times do you call eval in your production code, or never, right?
Never. Yeah. If I need to do 1 + 2, I just do 1 + 2. I don't need to eval 1 + 2.
Yes, right. So it's cool, but questionable. Like, what use would you get out of it? I think in the end, for us, it makes it so you can compile this spec namespace without it failing, because because it has a macro that has a eval call sitting in it.
So just another technical point. Whoever is controlling the thing, it's stuck on me.
Yeah.
I think that would be Mike.
Is it me that's controlling that?
Or wait, maybe Ray? Did you start it, Ray?
I started it, but it's not stuck on you. So
sometimes you have to toggle it to someone else and back, and it figures itself out.
There's also 2 Apropos in the little corner there.
Yeah, so, I see that as well.
Yeah.
Oh man, flail.
I say 3 now. All right.
Last time we had 5 Malias.
Yeah.
This is why I always tell my family that I have no idea how to use computers.
It's true. I mean, that's like people don't believe that I don't know how to use Facebook. And people are like, just go to your events and say you're coming. And I'm like, where is that?
I hate software. Like, I hate using software.
Yeah, it's still stuck on me. Ray, did you click around until it stopped, until it fixed it?
Right, it's off you now, I think.
No, it's not. It's still... Okay, wait. All right.
There we go. All right. Now it's on you. Okay.
Now it's swapping who's talking.
Yeah, Eric's going to get really self-conscious if it keeps pointing at him. So.
Well, it's weird because it's like when I'm not talking, I'm just like looking around, and then I see myself looking around 5 seconds later, and I'm like, oh, is that what I look like? There you go.
Oh, wow. We've got an uptick in people watching, I think, because they're expecting us to start the REPL.
That's
time.
Yeah. Actually, we've got a bit of bit of live feedback there in terms of the eval and apply stuff with people telling us that it's like Inception, I think.
Well, yeah. Let's get to the REPL. Give the people what they want. I'm going to read the thing. So we're about to switch over to the REPL. If you're listening on the audio version, we'll end it here. And you can go and watch the REPL coding on YouTube. All right.
Okay, so in theory now, should have it all being basically stuck on the REPL.
I see the REPL, yeah.
Yeah.
So what are we doing first? Some transducer stuff? Does anyone have... What's that?
Juxt. Just always juxt.
Always juxt? That's always awesome.
Eval. Juxt. Infinity.
Right.
There. I got both things in. So I guess there were some, after our coding last time of the one problem, there were some good solutions posted on Twitter that...
Sorry, I'm just kidding. Do the REPL, do the REPL, do the REPL.
So the kids are yelling McDonald's, McDonald's, McDonald's.
Yeah, that's right.
They love it. They can't get enough.
They cannot get enough of this REPL.
Do like an hour of REPL.
Yeah, we just...
No one wants to hear us.
I mean, after this, honestly, after this discussion about eval, I think we need it. You know, I think everyone needs it. Everyone just needs a good REPL now.
Yeah.
I mean, we should just talk about, whether Clojure is dying, stack traces,
That is the interesting
types.
Yeah. I don't know who put all these topics in the next show thing. These weren't very good topics.
It wasn't me. I never look at the Trello.
Well, I don't know if that's an excuse.
That's a lie.
Or
Well, let's not throw each under the bus, though.
No. only we just pick a scapegoat and that person takes it.
Well, I guess it was Mike.
Huh? What?
Okay, so Steve Miner had a pretty cool transducer thing that did use multiple arguments to the function that gets passed to map.
Yeah,
So
let's talk about that one.
Yeah,
Yeah,
because I think we mentioned that, oh, transducers can't do that,
right.
but I guess they can.
Well, I kind of question that. I wonder if his solution met what my definition of what I wanted was.
Yeah.
So essentially, he used sequence, right?
Yeah.
He used sequence to turn the transducer into a sequence. So the transducer was really simple. It was just this part of the code.
Okay.
So that makes a transducer.
Okay.
And then by calling sequence on it, it turns it into, is it a lazy sequence?
Yeah, let's talk about that form right there.
Okay.
I like it. Well, so what I wanted, if I tried to further clarify what I wanted, was some way to take multiple collections and cleanly pass them through, like this particular transducer that you have sitting there, and have it be
built in.
Well,
like have this cycle be part of it.
So if we didn't have sequence, if we just said let's do like an into a vector or any normal transducing kind of thing, what I would want is, well, what I think you kind of have to do is you have to take those two collections and you have to turn them into a single stream of things to go through the transducer by maybe mapping vector across them.
Right.
And by doing that kind of like leaves me less than satisfied, because you've now introduced a lazy sequence in your chain and your pipeline, and you're producing all these intermediate things that I want to avoid, right?
Right. Because this is a transducer turning it into a sequence, right? What he's got here.
He's followed the letter of the law, that's for sure.
Right, but what he hasn't done is captured this cycling between, positive and negative numbers inside the transducer. The transducer is this really simple thing here that is almost useless by itself. And so you have to, it doesn't capture the solution as part of its like wholeness. Right? It's lost its integrity as a solution.
If you do the source on sequence, I bet you'll see like lazy stuff inside there, or some sort of.
It's going to generate a lazy sequence, but I think it will work on a transducer that takes any arguments. So like the cycle is a sequence and the range is a sequence, but they could be core async channels, right? Because it is a transducer.
Okay. Yeah.
So
let's see if the definition of sequence is simple. That's small. What can you make of that?
So let's look at this simple case here, the transform and call collection.
Okay.
So it's transformer iterator. So it's going to create an iterator out of a transducer and then an iterator on that collection. Oh, so it is an iterator. So how does the iterator work on a core async channel? I don't know.
Very carefully.
Yeah, probably works. But.
So I don't
just by taking on the channel. So
sure, right. Yeah. Just waiting, blocking.
Yeah. I mean, the whole point about this thing was basically to share the underlying code, wasn't it, between sequences and channels?
Right.
But I mean, some people argue, and I think possibly correctly, that the sharing, the fact that you share these things make them both more complicated, or makes the fundamental code here much more complicated than the original. So there's always a cost of sharing code, isn't there? Because you have to introduce extra complexity, basically.
I really liked this other one that I'm about to paste in because, well, first it's presented as a transducer. It's a pretty cool, but it uses mutation to swap back and forth between -1 and 1. And then it does the multiplication trick on the numbers. So it's either multiplying 1 or -1. And then here's another thing I don't like about it, but it's also using the fact that vswap returns the new value.
Yeah.
And so then the fact that this is too clever, right? That it starts at -1. So
this is way too clever.
After you negate it the first time, it'll be positive. So the first one is positive, and the second. That to me is a little too clever. But I do appreciate that the a mutable version of this transducer is so small. I do like that. Even though I don't want it, I would never use mutation for that.
Oof! I just paged over. It looks like we're not seeing the REPL on the feed right now.
Yeah,
right.
Sorry, I've got a little network issue here. Just 1 second.
Yeah, so we should get that back up and running. And then a couple people have had questions about what transducers really are, which is always a fun conversation. We might, I don't know if we want to like do what are transducers next episode or talk about them here.
What are transducers?
Right?
So the best.
That's
the best.
All right. Eric is up now.
I'm up again. Do we have a REPL thing up? No. Okay, I'm gonna talk while Ray.
It's coming. It's coming.
All right.
It's coming.
So I've heard from Rich Hickey. He explains transducers as if you do a map, it assumes that you're working on a sequence. That is part of the code of map, that it's like recursing through a sequence, building a new sequence. And he wanted to capture the idea of the actual work that is being done on each item outside of the idea that it's being done on a sequence. And you might think that that's just the function that you pass in, but then that function can't be applied equally to something else like a core async channel, or it doesn't compose with a thing that's doing a filter. And so he was trying to come up with a way to represent those kinds of operations that work generically on different kinds of structures.
All right, it looks like we've got the REPL up. Thank you. And then Angus posted, like, sort of the way I've always thought of it. He says they're sort of like reduces, but reduces have to know what they're reducing to.
Well, I mean, the way I think about it, and the way that he explained it, actually, that Rich explained it anyway, was that that you remove all ordering concerns from the sequence processing, and that was the important aspect. I thought was that you didn't have to have the processing of. If you're doing reductions, the things have to follow each other actually, because 1 plus 1. Well, when it's plus, it doesn't matter, because it's all just it doesn't matter how you add numbers up. It all just ends up being.
If they're ordered, if the expressions are ordered in any way, then they have to.
If there's a dependency on order, then
yeah. But I think, Ray, you're thinking of reducers. So reducers removes the dependency on it being.
Could be
in a sequence, and so that it can be done in parallel. But transducers is making it so that you don't care about the underlying structure at all, but it is still done in order.
Yeah,
it's not done in parallel.
Because you can have stateful transducers as well that depend on the state as it's flowing through there,
and it's all. Go ahead.
Yeah, in fact, I've even written a stateful transducer. So
someone used the devil
for
emoji.
a good reason as well. Yeah,
a good reason. What was the good reason?
For a good reason. Well, we were in a previous job. We were looking at scanning we were looking to bring back a small segment of large files. So assuming you had like a 2 terabyte blob, then in HTTP you can ask for just a specific part of a file. So the idea was to take all of the links, scan forward to the point where you start to read. So the transducer didn't do anything, didn't really kick in until you started to read the bytes from the files. And then once you'd finished reading, then you could just stop the transducer. So that's the other thing you can do with the transducer as well, is you can stop it early. You don't have to process the whole collection.
Oh, that's cool.
Yeah. I mean, it was for, like I say, for potentially very big files, so it had a good purpose.
Yeah, I mean, in theory, the transducers can operate on huge data because it can all just be streamed through, and you never have to read more than a chunk at a time.
Yeah.
Yeah, we use them to in some of our tests for Kafka streams.
Yeah.
All right, it looks like the REPL is back up on the feed.
Cool.
Let's do something then.
We could try solving that little problem that we have
The
next to
little
last.
problem. Yes.
The sequence of
let's
digits
do that.
I'm
problem.
going to paste it into the chat. Someone can start it. Mia, would you like to start?
No.
No?
Ray?
I think I just can remember what the solution is, what the problem is.
The
Okay.
problem. Given an integer, return a sequence of its digits. So 4532 gets turned into the sequence 4532.
Yes.
And then provide the inverse as well as a bonus.
Extra
I think
credit.
I did
yeah.
something like let s, and I think I did a cheaty thing, like I said, integer dot. Did I do string or integer? I can't remember which. Parse int. 2, 1. Let's just do that.
Okay.
Actually, see what that
Maybe
gives
put a
us.
slash there for integer.
Yeah, I wasn't sure how much Java interop we were allowed to use here.
Okay.
Jesus,
No, that's
just a
fair.
while.
All's fair, right?
So you're parsing an int from an int.
Oops.
Yeah, you need to pass a string to that maybe.
So just to
What's
be
the
clear,
question again?
we're starting with an integer.
We're starting
We
with
turn it into a sequence of integers.
So it's string parse int, isn't it? Actually.
You can
No,
actually
just
just do
str.
str there. Yeah, you can just do str.
Oh, that's nice. Okay.
Yeah, okay. So that does the equivalent of everything else. Yeah. So then you just I guess you just reverse it. Yeah.
No, we're not reversing.
We're not reversing it.
What we're doing?
We're trying to turn it into a sequence of integers.
A sequence
where
of
each integer is a digit. So the first integer in that sequence has got to be the integer 4.
Are we allowed to use read string or no?
Fine, yeah.
I guess so.
Oh,
You can use a val if you want to. I mean, I don't care.
Well, isn't this where you can do the integer actually? Integer parse int. Integer parse string even.
Well, I think maybe you might want to take a minute or two to read the problem, Ray.
Fuck it. Someone else do it. I thought I already solved this in another world, another life. So
I would.
I'll go back to my notes.
My first inclination is to not go to the world of strings. My mind starts to do remainder.
ooh.
So this will get you.
Remainder.
If we did like 532 is the sample that we have that we want to turn into the sequence. So this gives you the last digit by itself, which is part of the answer. It's the last part of the answer that you want.
Mm-hmm.
And then if you do integer division, Clojure is named quote for quotient. It's the same thing as I think slash and C, whatever. That gives you the other part. And from these two things, you can kind of see how you might build a solution. So let's see. I think I want to make a recursive solution out of this, but I'm not sure if I want to.
Do it.
Do it. Let's see. And then I think I might get the answer backwards, and then I'm going to cheat and call reverse.
Okay, and then I'm going to show you the Java version that I did.
Let's see. I don't know. In.
Uh-oh, we lost the REPL again.
Did we?
Uh-oh.
There we go.
Okay, so let's see. I want to, let's see, I can't remember. I have this going to be part of what I want to pass out. I'm just going to cons that onto what I would get if I did the rest of it. Let me try it and see what that does. 5, 4, 5, 3, 2. So I need a stopping condition, right?
Yes, base case.
A base case.
Probably 0.
That's why everyone loves recursion.
Let's see. Let me just slap a win on there.
Yeah.
Let's see. When n is
0? Equal to 0? Oh, I see. Yeah.
I'm not sure, to be honest.
I bet
so
the case of when it actually is passed in. 0 is passed.
I'm going to do an if instead. I'm going to say if n is greater than 10, do this stuff. Now I need to figure out where to put my thing at the end. That's my attempt at a base case. Let's try this one. Why did I get that? I seek from long.
Because you're consing, and you're consing onto, so in your then or your else
is slightly odd.
Is that better?
Yeah.
All right. Oh wow.
Whoa.
It worked, kind of.
Sort of.
Now I'm just
You already reversed it.
Yeah.
Yeah.
So this is perhaps
because that
inefficient.
recursion reversed it. Yeah, awesome.
No,
Yeah.
you can't reverse it. You're reversing every time now.
Oh,
wait, would
thank you, Eric.
conj instead of cons still do the same thing? I
Ooh,
always
if
forget
you
how it
used-
works on the
if you
different
used a
collections.
vector, if you used a vector,
Yeah.
but then the order
Okay,
changes,
let's see.
and then it's not lazy anymore. But that's okay.
Let's see. So I need to change. Do I need to put my vector here?
No.
No?
Just delete the remainder and put it at the end.
I think that's what I need to do. Where is the end now? Around here.
Yeah. No.
Move off by 1.
Yeah, close it right after the quote and 10.
Right here.
Mm-hmm.
Yes. Let's see. Normally, if I were in an IDE, this would be easier to do.
Yeah, for sure.
Yeah.
That's why we have pair programming, so you don't need an IDE.
Woohoo!
Yay! Now try
Right.
0. See what happens when you do a 0.
Oh, you're going to break it, aren't you?
Maybe it'll work. Okay, now try 1.
Okay. All right.
Oh, awesome.
It worked.
Great. It worked.
Beautiful.
Hey.
Okay, how do we do the
Okay.
inverse?
I bet the inverse is easier. Or maybe not.
I think it's going to be, if we can do it in a similar way, which is multiplying by 10 and adding recursively.
Yeah, the inverse is extremely easy if you're allowed to use strings here.
Yeah.
Yes.
Because you can almost just read it off, right?
Yeah.
So can I attempt this inverse?
Yeah.
So we're going to do ints just to keep the same naming scheme. And it's going to be digits.
Yeah.
So we have an empty digits. I guess it's 0.
Okay. Are you doing recursive solution and you're thinking of your base case right now? Okay.
So I'm just going to take the first and the rest.
Okay.
Structure that. And I'm going to... no, I can't do recursive now. I need an accumulator. Don't I? No, I don't. Okay, I'm going to do... No, I do need...
Let's see.
Hold on, let me think about this. All right. Yeah, I need to do it backwards.
Because I guess you get stuck on what do you multiply the f by? What do you multiply the first by?
Right, because you want that f to be recursed the most because it's going to be multiplied by 10 as many times as there are others.
Okay.
So it's going to be deeper in the recursion, which means you want to reverse it.
Rebel's dead.
Dang.
Why? Looks okay.
There.
It came back. Yeah.
Came back? All right, cool.
Oh, I think what it is if I'm on the laptop and I go into a full screen thing, then it dies. My mistake. Okay. Sorry, guys.
I mean, the easy thing would be to just do a loop inside of the function.
Okay.
And reverse it the first time.
Okay.
And then have a if empty base case, we'll just return a 0. Otherwise, we'll destructure. And now we're starting with the units. So we just return it.
Okay.
And hold on, digits.
So f will be the units?
No, sorry. This is wrong. Oh, I can't. What do I do now? We need a Rebel read line or something.
Yeah, to edit multi-line forms. Yeah.
Yeah. I think I might need 2 base cases. Should never get to an empty digits. Let's assume that. Okay, so here's my base case, there's no more results.
Okay.
Just return F. There's no more rest. Otherwise, do plus F times 10.
Okay.
And then recurse. I can't recurse here because it's not tail recursive.
Oh shit! Yeah.
But can
You're
I do
stuck down in a
int?
Yep, you can.
That's why I should have an accumulator. See, that's the thing. It's going to reverse it.
It's going to reverse it again each time. Yeah.
So I'm going.
But you could take that out into a separate function. Yeah. Or whatever.
Well, yeah, I'm going to make it into a.
I tell you, the live stream is loving all this.
The flailing. It's not coming. Yeah, it's like a drama. Like, how does he get the accumulator? Oh no!
Everyone's just whispering, "Use read string."
Well,
Yeah.
just to satisfy people, like this is like the end of Act 2.
Yeah.
You know, it's
Well,
just
after this bit, I was going to say I would quite like to do the Java version, just so that.
No, don't use read string. Oh no.
it's too easy. Okay, so that's why we're going with this one. It's too easy. So I'm going to reverse the digits. I'm going to do a tail recursive version. And there's an accumulator, which is going to start at 0.
Okay. Yeah.
So in the empty case of digits, I'm just going to return the accumulator. Otherwise, I'm going to destructure it and get the digits there. And now I'm going to do recur
first, yeah,
on the rest and plus f times 10 accum.
It's worth trying. Yeah.
int 4 5 3 2. Oh, it's backwards.
Oh man.
Okay, so let me
get rid of your reverse.
The reverse is probably jumping the gun.
The reverse is going to be. Hey.
I love this editor, huh?
Yeah. I've done this many times as well.
I know me too. So many times, man.
Not until we get REPL readline. Yeah. Or Rebel
readline. I tried it the other day. It's actually really nice.
Yeah.
Okay.
Okay.
There.
Woohoo! That is awesome.
Beautiful.
Using only pluses and times 10s.
Yeah.
Whoa.
But the lesson learned there was you kind of got down into a corner where you wanted to recur and you realized, oh crap, it's not in tail position.
Not tail position.
Yeah.
Here's one
So
from the YouTube comments.
Okay.
Unmatched delimiter, bud.
Right. So it's must be before the unmatched delimiter.
Can I give you a Java version?
Oh.
Ray really wants to do the job.
Oh, come on.
Ray, have you forgot what language this podcast is about?
It's rough.
Invalid number 4. I think there must be something messed up. Let me retype it.
Maybe 4 just isn't a valid number.
Yeah, 4. Definitely not.
I think they canceled 4's contract.
It's out.
So what is that thing doing? It looks interesting.
I don't think that's right.
532, 4532. It's sort of like repeating itself.
So in this case, change that to reductions. Just it's a good lesson to learn. When you see something weird like this, change reduce to reductions. And you'll see the sequence that it's building up.
Wow.
I didn't know that one. Yeah.
It's a good debugging tool. Sometimes it's useful for actually solving a problem.
Why did it work this time and not the last time?
Yeah.
Instead of a print. Oh, I see.
Oh, okay.
Oh, okay.
Weird. Okay. Cool solution.
Cool. Yeah, that's nice.
Use reduce to do the same calculation instead of. Oh, and then you don't have to reverse it, huh? That's a good idea. Really good idea.
Okay, Ray. I think you're allowed to do your Java solution now.
If you must.
I kind of don't want to now.
You must.
How's it going?
I know. Yeah, we've got a new Ray now. That's a joke.
Yeah. Nice.
String join.
Yeah.
Okay.
Parse int. Yeah, I'd rather do a parse int than a read string, because the read string could be anything, right?
For security reasons. Yeah.
Yep.
For security reasons.
Yeah.
But because especially this, you're assuming that's a sequence of integers, but you just joined them, and it could be a whole bunch of, you know,
junk. Yeah.
This is a work computer. I'm not allowed to do read string at all.
Really?
It's against policy. Yeah.
Because the other way, I mean, again, this is like, okay, it's sort of Clojure type thing here is to do int to seek, and you have to do all this crappy thing. But if I then do that.
So why are you doing an into vector?
If I take 1, 2, 3, 4, so I say, oops.
Okay.
I have to type.
Okay.
So then, well, what would you suggest rather than just do a vec or something? Or
into vector, because a string already is a seek. That's what I'm.
Oh, okay. So
maybe you could just eliminate that. Yeah.
Get rid of the into. Oh my god, this is so annoying.
Oh, come on, Ray. You've done this before.
Yeah. You have to remember to make the right fix.
That is one of the problems with this, is you forget what you were trying to do because you're hitting up so many times.
Now I have to get
rid of one more. Yeah.
Yeah, and then get rid of that one at that end as well. Like, you can't tell because I want to. Yeah, I think that's it. Okay. There.
Oh, you missed it.
There we go. Oh yeah.
There you go.
Yeah, good point. Yeah. Unnecessarily extra into there. So, and then this one becomes relatively easy to. You can also, with this one, you can do this. So it doesn't have to just be a sequence of numbers. It can also be sequences of strings.
Yeah.
And the pièce de résistance is the check that works both ways.
Nice.
That it's an inverse.
Yeah.
Right. So can we talk about style for a little bit?
Do we have to? I'm not dressed for it.
I noticed you used comp. You used comp, right?
I used comp, yes.
But you used comp with a
straight out of Compton.
With a function. So I'm gonna paste it in.
Yeah.
Okay. I mean, sorry, no, it's okay. Joke, it's fine.
It's good.
Yeah. Okay. Good. Right. Good. Comp. Yeah. What we're really talking about.
Comp is cool. But then I try to avoid it if I can, because I feel like it complicates things. So like, I mean, this is just stylistic. Because you're already making a function, I would just do that, right? That would be my thing. Or even like, I don't know, I might do something like this. I feel like it. But I think I would prefer that one. Just because you're already making a function, like why make a function to just compose it with something else? We have full code in there. I like to use, I don't know. That's just my stylistic thing.
Yeah, I wonder what cases comp starts to become a better way.
Well, definitely if you already have a parse int, right? So if you have something that's like parse int that you already wrote somewhere.
Okay, yeah.
And so you can be like point free, not make a function, a new function. I don't know. What do you all think about that?
I think I tend to use comp less frequently than the other forms you suggested.
Yeah, I've actually never seen comp used in production code. Like I use it in the REPL when I'm just testing things, but it's not.
I like comp. Okay.
It looks cool.
Point free. Yeah.
It looks cool. I like point free better than. I kind of go backwards and forwards on this threading business.
Yeah.
Yeah.
I'm not a
threader.
I'm not a threader because I think the reason is that because like you've got this thread, you've got this arrow with one chevron, an arrow with two chevrons. And you have to remember that, okay, yes, that's the first argument, that's the last argument, and that's a bit that, yeah, it's a bit.
Ray, I've never met anyone else who also doesn't like threading. I don't like it.
No.
Oh.
I just don't like it. There's two of them. Sometimes there's the one kebab. Sometimes there's a double kebab. Yeah, and it gets when you're teaching it. The thing that bothers me about it is you're teaching Clojure to someone, and they've finally gotten used to sort of reading the functions in an order and unpacking them and working with them, and then you give them the two different threading macros. And they're like, "Why? What are you doing? Why did you do this to me?"
Yeah,
that's really interesting because I find that if you introduce the threads earlier, the beginners like to see that stuff is happening in an order instead of reading it inside out.
Yeah, I mean that's fair. Yeah, you gotta. Yeah, if they have to be introduced immediately, because otherwise it kind of feels like you're breaking some kind of contract with someone.
One thing I didn't get about
go on.
I was just going to say one thing I didn't understand for the longest time about the threading macros when I was first learning Clojure. I kind of thought that it was, I guess, more like comp, or it was taking. I thought of it as taking the results of the innermost one and passing it as the input to the next, and kind of like chaining things along. When really it's more of a syntactic thing.
Syntactic,
yeah. And that took me months to figure out. Yeah.
The thing that I found weird about it is that I only use it as a kind of a way to make code a bit easier to read. Actually, I don't find it's a way to write code more easily. I find it very annoying to write code that way, frankly. I much prefer the point-free approach to writing the code. But then I think, yeah, okay, maybe I can thread this so it becomes a bit more easy to read. Now I've actually worked with it and worked at the REPL and made it all work. Then I can make it easier to read by using the threads. But I'd never use the threads to develop with, almost never.
Really? See, I find that there's a lot of cases that I don't know, I didn't like threads at first either, but I worked at a company where they were like very thread happy. And so I just adopted the style and I started to notice that there were a lot of cases where I really liked it. So like, let's say you have some X. So if it's a data structure, you could do a get in X and then dig out something, and, do whatever here. But then what happens is like, well, I want the first thing. Well, it's a vector, so I could put a 0. But then, oh no, I want the last thing. How do I get the last thing out? Well, if you take this and turn it into a thread, and you do X and then foo and then bar and then last, so you're actually able to capture that in a single expression. And then you can say, oh, and then I want to turn it into a string, and then take the, you see what I'm saying? Then take the like third element of the string, etc.
Yeah, doing stuff within nested data structures is absolutely the best case use for the threading macro. It's just much nicer. It's much easier to read. It's much easier to write.
Right. Because there's a fine line between access and type conversion, right? Like I did the toString, and like sometimes it's like, okay, I got the thing. Now I need a string version of it. And so you're right in the thread. Just put it in there, and then you can trim, right? And so there's all sorts of like little manipulations that do chain really well, that you would normally chain, like in an object-oriented language, you would do a dot, 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 dot. And I find that for this kind of thing, it works super well.
I do find that I'm kind of like Ray in the sense that I will start writing it the normal conventional way without threads. And then I'll have like 3 of them stacked up and I'm like, this is getting hard to read. And then I'll refactor it to the thread.
Exactly. Yeah. Also, I mean, the way I think about it is that there is one way to read Clojure, which is the way you read any Lisp. And then there's the weird way, which is with the threads.
Yeah.
Which is, I mean, you know, you can't, you know, the threads is odd, I think, because the rest of Clojure is not like that. No, exactly, yeah. Well, I don't know the full history, but certainly the, you know, to me, the vast majority of Clojure code you see is not threaded. So there's, you know, you have to know how to do this right to left thing.
Right.
You know, you have to know it's inside out, right to left, whatever, you know.
Except, don't you write the code inside out?
Mm-hmm.
Yeah,
so
I do.
Right from right to left, and so then you have to read it from right to, you know, so. But then a thread, you write it top to bottom and you read it top to bottom. So it's like, I don't know, it's the same. It's just. So I'll tell you, I might have written your solution. I'm gonna try to reproduce it here. The map comp. Let's just do foo bar and then some collection. I might have written that as call map bar map foo, and just eating the cost of the extra lazy seek in there. I mean, to me this is really a lot easier. Like take it, turn everything into a string, and then parse everything or whatever you were doing. I don't even remember. But
yeah, well,
whatever bar and foo are, instead of the comp, I'm going to put them side by side here. Instead of the comp foo bar, which is basically saying do bar first and then run foo on the results. Like I find that this one is way more clear.
Yeah, I must admit, I mean, the common use case for comp in my experience in actual real code is where you've got a partial function which you're currying, and then you compose with another function. But that's not the case here. But so I think comp and partial work very nicely together, and that's the reason why threads are a bit off, because you can't.
Right.
Yeah.
Well, we're now over time.
Should we see if anyone's had any great insights in the Slack or in the e-juices? Oh my god, fucking yeah. You can use e-juices, says Angus Fletcher, but nobody does. Yeah, that's correct. Maybe next week we'll use e-juices for something. I'll have to look it up in the meantime.
Yeah, there's a pretty cool discussion. So if you're watching this later and not live, I think we'll have the chat in there, right?
Yeah, it is actually kind of in sync with as it plays the chat in sync.
Cool. So they'll have to wait until just now to read. That's cool. Yeah. There's a really cool discussion in here. I'm sorry I haven't been reading it as I've been typing.
Yeah, no, it's really good. Yeah, so yeah, we're getting better at this kind of like we're live typing with all that sort of stuff. Then we watching the live stream is a bit tricky. Yeah, but it's good. Yeah. Anyway,
so the consensus on threads is sometimes they're good, sometimes they're less good.
Right. No.
Perfectly put.
We need a language where there's no less good ever. It's always more good.
What's that? The painter guy, Bob someone.
Bob Ross.
Bob Ross. Yeah, that's the Bob Ross approach, isn't it?
There's no mistakes. There's only happy accidents.
Excellent.
Yeah. Good mistakes. Good trouble.
He's a good painter, though. I don't know if you've ever tried to make some happy accidents on a piece of canvas. They don't look like a little happy tree. No, it's not a tree. That's just a smudge.
Yes, I like that. Only happy exceptions from Angus there. It's a good one. All right, cool. Well, yeah, we flailed. We lived up to our contract of flailing big time this week. Yeah.
Too many reverses.
Oh man, yeah. the cost of recursion. The curse of recursion.
I love how there was just a simple reduce solution.
No, that reduce was so nice.
Right.
Yeah,
It's like,
yeah.
damn it. I'm supposed to do it. I remember, so I worked in Common Lisp for a while, and you do reduce every now and then if you had to add up a bunch of numbers, you do reduce plus on the list. But it wasn't until I got into Clojure that
Should I kill the REPL, by the way, and we just finish off for 5 minutes while we're doing that? Yeah, okay, sorry. Yeah.
Clojure was the first language where people were seriously using some reduce.
Really?
And I started like trying to make mental note, like don't make a recursive function. Just try it with reduce first, because it's probably easier to make a reduce. And I didn't do that.
Like if you think of this stack of abstractions or whatever, you have like loop recur at the very bottom, like the most basic, and then reduce is like one level up from that. Then you get up to like the map and stuff like that.
Mm-hmm.
Yeah.
So reduce is like a low level, fairly low level, broadly applicable thing.
It's your like hammer.
It's like the universality of fold, whatever that paper was. Everything can be written in terms of reduce, really. The magical function that can do it all.
Yeah. Maybe we should do some reducing type things next week then. There's a bit of fun.
Yeah.
That sounds good.
Some katas with reduce. Yeah.
We should do some really hairy kata and just turn it into a very simple reduce.
Yeah, but it's so satisfying, even when it's someone in the chat doing it, when you have something very complicated and then someone's just like, oh, have you used reduce?
Right. And folks, don't do a nested reduce. A reduce with a reduce in the function that you passed? No. Sorry.
Yeah, do it.
do it, and then regret for the rest of your life.
We want to see some ugly code out there.
Yeah, send us please tweet your absolute worst code at us.
Yeah, actually, we must next week. We must. Well, we can look at the Twitter feed, but Michael Borkant's stateful transducer to do the flipping of the numbers was unbelievably bad, and he put a devil's horn in it, so he got a pass. But yeah.
Okay, people, I want to see a stateful transducer that takes a sequence of digits and turns them into a number. I don't even. Yeah, it's gonna have an eduction or something.
Yeah. Someone's got to do an educe. Yeah.
Where like the state is like what digit you're on, like what place you're. Okay.
Okay, I think we're gonna call it a day.
Yep. Yeah. I gotta eat.
Bye, everybody.
All right. Later on. Bye.
Bye, everyone.
Bye.